Hello again. This lesson, we're going to be doing a number of things. We're going to be writing expressions. We're going to be substituting in for those variables in the expressions we've written. We're also going to be using those expressions to solve first one-step and then two-step equations. So first of all, we need to take a look at our scenario. Our directions, of course, tell us that we're going to be writing let statements. And we use those let statements always to describe an expression. And we need to do that for this given scenario. And the most important thing that we need to remember is that we only use one variable for each, every time we do this. So the entirety of this will use only one variable. So my first let statement, I always need to figure out what's the first thing I don't know. Whoops, that's silly. The first thing I don't know. So our first piece of information says that in minutes, it takes Sophie twice as long to get to school as it does Matt. So if we know Sophie takes twice as long as Matt, we know that the first thing we don't know is how long it takes Matt. So I'm going to say let M equal the number of minutes for Matt to get to school. And then, whoops, and then of course we know the reason we knew that Matt was the first one that we didn't know is because we knew that Sophie was twice that. So let, twice means to multiply by 2. I always do that by having my number and then the variable, 2m, not any of the other ways that you do it, and especially not M2. I have seen some people doing that. You don't want M2. That's silly. That's like saying desks 2. You would say 2 desks. So here we are. Let 2m equal number of minutes for Sophie to get to school. Okay. The next person is Jacob. He can get to school in 3 minutes less than Matt. So we have to go back to see what the expression is for Matt. The expression for Matt is 2m, or excuse me, is m right here. That's for Matt. So I know I'm going to start with that for Jacob's. And then it's 3 minutes less. So less means I'm subtracting. So I've got m minus 3 equals the number of minutes for Jacob to get to school. And then the last one, we have Kayla. And Kayla, let me see, can get to school in 5 minutes longer than Sophie. So we have to go back and see how long does it take Sophie to get to school? 2m. So we know we're going to be starting with that. We've got let 2m and 5 minutes longer. So longer means we're going to add to it. So it's 2m plus 5 more. And that, of course, equals the number of minutes for Sophie. No, for Kayla. Sorry, Kayla. I'll fix this right now. I immediately looked up and saw Sophie and knew I'd done that wrong. That was silly. For Kayla to get to school. Okay, so there are our let statements. Remember, the purpose of our let statements is to describe each of our expressions. And we wrote 4 let statements because we have 4 expressions. So I just want to be very clear what we're referencing and why. So these 4 that I just highlighted are the expressions, and the let statements describe each of those expressions. So moving right along, that takes care of part 1. Next, in part 2, it says, if you know that Matt can get to school in 5 minutes, how long will it take everyone else to get to school? So, Matt can get to school in 5 minutes. Well, Matt's the first one we started with. His expression was M. We put a semicolon. M equals, tells us right here, 5. And then I substitute in, and I say 5 minutes for Matt. The next person, moving right along, is Sophie. So that's 2M was the expression for Sophie. I put a semicolon to separate what M is equivalent to in this particular problem. I substitute in 2 times 5. Funnel down, 2 times 5 is 10 minutes for Sophie. And next we have Jacob. The expression for Jacob was n minus 3. I have to put my semicolon. M equals 5. Substitute in 5 minus 3. Funnel down, that gives me 2 minutes for Jacob. And my last expression is for Kayla. The expression for Kayla was 2M plus 5. We know that M is equal to 5. We substitute in, we've got 2 times 5 plus 5 more. 2 times 5 is 10 plus 5. Still funneling down just like we've been doing since the beginning of the year. So that is 15 minutes for Kayla. So just to be clear, the answers we have here, we've got 5 minutes for Matt, 10 minutes for Sophie, 2 minutes for Jacob, and 15 for Kayla. But again, it is very important that we show all of this work. That way, if we do make a mistake or if we want to show someone how we did it, it's very, very clear. Okay, moving right along, part 3. You know that Sophie can get to school in 12 minutes. So therefore, how long will it take everyone else to get to school? Well, if we look back at our expressions that we've written from the start, and we know that we have an expression for Sophie now, and we also have a number. So this is where we know that we're going to have Sophie equal to Sophie. I know this seems very strange to some of you, but that's how we set it up so that we know we have everything we're supposed to. So for the first Sophie, I'm going to put the expression that we wrote, which was 2M. And for the second Sophie, I'm going to put the number that's been assigned for Sophie, which is 12. And now it's a simple one-step equation that I'm going to solve. I say what's the opposite of times 2, because remember 2M is meaning that M is being multiplied times 2. So the opposite of multiplication, of course, is division. We divide both sides by 2, and it should look like this. It should look like a fraction. We are in 7th grade now. Those 2's cancel out. I'm left with M on this side equals 6. So I know I'm going to be using this M equals 6 to now substitute into all of those expressions that we wrote in the beginning. So the first one I'm going to do is M equals 6. I substitute in 6, and that's 6 minutes for Matt. The next person was Sophie. Sophie is 2M, and M is equal to 6. I know you're wondering why we're doing this one. We'll address that in a moment. I substitute in 2 times 6, and 2 times 6, of course, is 12 minutes for Sophie. Now, why did we do this? We already knew that Sophie had 12. Why would we do it again? Well, the very simple case is that we want to compare and make sure that this M equals 6 over here that we used here, let me use a different color to highlight that, sorry. And then when I compare them, this 12 minutes, it should be the same over here. So that's why we do that. It's kind of like a safety check, a place to check our work, make sure that we did it correctly. So now, moving right along, we next are going to do Jacob. Jacob's, whoops, I got to get out of my highlighter, sorry about that. And m minus 3, m equals 6. Substitute in 6 minus 3 is 3 minutes for Jacob. And the last one is Kayla, and that expression that she has is 2m plus 5. Put a semicolon always to separate it. Make sure your semicolons don't look like j's, because sometimes we use the variable j, and that becomes very confusing. M equals 6, so I've got 2 times 6 plus 5. My order of operations tells me to multiply first. 2 times 6 is 12, plus 5 more is 17 minutes for Kayla. Okay, moving right along here. The next thing we're going to do is this last one that we have here. Kayla can get to school in 13 minutes. How long will it take everyone else to get to school? So this is similar to the last problem, but there's actually an extra step. So again, we're going to have this Kayla equals Kayla. And you should get used to doing this and seeing this, even though it looks funny at first. So the expression for Kayla we knew was 2m plus 5. And the value that's now been assigned is 13. So those are the two things that have been assigned to Kayla. And now we solve this. Now, this looks a little bit more difficult to solve because we now have to use 2 steps to solve it. If I were to look at this, 2m plus 5, and like I said before, the order of operations tells us to multiply first. But because we are going backwards, we're going to do the, we're going to follow the order of operations backwards. Okay? So when I look at this, the first thing I need to address is the positive 5, or the plus 5. So the opposite of plus 5 is minus 5. Now, it's very important that whatever you do to one side, you do to the other side. We think of it as a seesaw, and we want it to never tip to one side or the other. I subtract 5 from both sides. These two cancel. I'm left with 2m on this side, and 13 minus 5 is 8. Just like before, the opposite of multiplying by 2 is to divide by 2. Those cancel, and then m equals 4. So now I'm going to use this information to substitute into each of those expressions. And we've done this now. This is the 3rd time we're doing it, just with different variables. I know that m is now equal to 4, so I substitute in. That's now 4 minutes for Matt. Next we have Sophie. Sophie's expression was 2m. m is equal to 4. 2 times 4 is 8 minutes. That's for Sophie. Kind of went off the end there. Sorry, Sophie. And for Jacob, we've got m minus 3, semicolon, m equals 4. Substitute in 4 minus 3. That's 1 minute for Jacob. And then the last one we have Kayla here is 2m plus 5. We know that m is equal to 4 as an equal sign. I substitute in. I've got 2 times 4 plus 5. 2 times 4 is 8 plus 5 is 13 minutes for Kayla. And there you have it. We now have all of our parts done. We've done a lot in this video. Make sure you took good notes.